If we take a system and we rewrite it as an augmented matrix, we can use row operations to solve the system. So the first step is to write that system as an augmented matrix, and then we are going to get our system, our matrix, into row echelon form. So we're going to obtain a row in the first row and the first column, and we can do that by interchanging two rows or multiplying the row by a non-zero constant. Then once we obtain a row in a column, we're going to get zeros in the column also. So to get zeros below the 1, we are going to use that 1 by multiplying that 1 by whatever it takes in order to eliminate the values below it. So we're going to replace the row, not necessarily the equation, but the row by the sum of that row and a non-zero multiple of any other row. So after we get our 1 in the column and the zeros in the column below that 1, then we move to the next column and we get 1 and then zeros underneath it. And then we keep going down until it's in row echelon form. So let's take a look at an example. So here we have a system of equations. Let's rewrite it as an augmented matrix. So we have 2, -4, -16, 3, 5, 9. Now we want to obtain a 1 in our first row and our first column. So I can take this 2, and notice that if I just interchange two rows, it's not going to help me any. So I'm just going to take and multiply 2 by whatever it takes to get a 1 there. So I'm going to multiply this row by 1/2. So this would mean that row 1 would equal 1/2 of the old row 1. And so the result would not change row 2. But the new row 1 will be 1, -2, -8. Now that we have a 1 in the column, we're going to get zeros below it. So we need 3 to become 0. So I'm going to replace this row with a multiple of this row added to it. So what can we add to 3 in order to make it 0? We're going to multiply this row by -3 and add it to this row. So just so you know, this is not standard notation. This is just a helpful mnemonic device that I use to help students see what's going on. So what this means is that row 2 is getting replaced, and it's getting replaced by -3 row 1 plus old row 2. So row 1 is not changing. We have 1, -2, -8, and then we're going to take 1 times -3 plus 3, and that gives us our 0. -2 times -3 plus 5 will be 6 plus 5, which is 11. -8 times -3 is 24, plus 9 is 33. Now, we move to our next column. So notice we had 1 and then zeros below it. Let's move to the next column. We need, in the next row, a 1. So let's get a 1 right here. We can get a 1 there by taking row 2 and replacing it with 1/11 of that old row 2. And so this yields for us an unchanged row 1, but 0 times 1/11 is 0, 11 times 1/11 is 1, and 33 times 1/11 is 3. Now, this is in row echelon form. Since it's in row echelon form, let's rewrite our system. We have x minus 2y equals negative 8. Y equals 3. This is the corresponding system to that augmented matrix. But we know that y equals 3. So let's back substitute. And x minus 2y equals negative 8 will be the same as x minus 2 times 3 equals negative 8. So x minus 6 equals negative 8 means that x equals negative 2. How can you be sure that this is our correct answer? So we've just said that our answer is negative 2, comma 3. We can check that by substituting it in. So 2 times negative 2 is negative 4, minus 4 times 3, that's negative 12. Negative 4 minus 12 is negative 16. 3 times negative 2 plus 5 times y would be 3 times negative 2 plus 5 times 3, that's negative 6, plus 15, that's equal to 9. So negative 2, comma 3 is our answer. Now let's look at a system of equations that has 3 equations and 3 variables. Again, we start off by writing it as a system of equations, as an augmented matrix. So 2, negative 1, 1, 13, 1, 4, negative 2, negative 3, 5, 3, negative 6, negative 40. Separate the right-hand side from the coefficient matrix. And now, let's begin. Can we get a 1 in this first column, first row? And the answer is yes. I could either take this and multiply it all by 1/2, which would be fine. That would give me a 1 here. Or we can interchange 2 rows. So let's interchange these 2 rows. So we obtain 1, 4, negative 2, negative 3, 2, negative 1, 1, 13, 5, 3, negative 6, negative 40. Now that we have a 1 in the column, let's use that 1 to get zeros below it. So we need to get a 0 here. So I can add negative 2 to that. So let's multiply by negative 2 in that first row and add it to our second row. So the proper notation would be row 2 is getting replaced by negative 2, row 1 plus row 2. So we have 1, 4, negative 2, negative 3. So now our second row will be 1 times negative 2 plus 2. That's our 0. 4 times negative 2 plus negative 1 would be negative 8 minus 1, so negative 9. Negative 2 times negative 2 is positive 4, plus 1 is 5. Negative 3 times negative 2 is 6, plus 13 is 19. And our third row did not change. So now we have a 1 in the column, we have a 0 below it, we need now this 5 to be a 0. So let's multiply this by -5 and add it to this. So this would be row 3 is getting replaced by -5 times row 1 plus row 3. So what's this yield? Our first row doesn't change. Our second row does not change. Our third row will be the first row times -5 plus the third row. So 1 times -5 is -5 plus 5 is 0. So notice we have the 1 in the column and then zeros below it. Now 4 times -5 is -20 plus 3 is -17. -2 times -5 is 10 plus -6 will be 4. -3 times -5 is 15 plus -40. So 15 minus 40 is -25. So we have our 1 and the zeros below it. Now let's move to the next row. Can we get this to be a 1? And the answer is yes. Let's multiply this row, row 2, by -1/9. So 1, 4, -2, -3, 0, -17, 4, -25, and then the second row changes to -1/9 of that row. So 0, 1, -5/9, and then -19/9. Now we're going to use the 1 here to get a 0 here. So we want this to be a 0. So we're going to take this row and we're going to multiply it by +17 and add it to this row. So the first row doesn't change. Our second row doesn't change. Don't be scared about these fractions. So now 0 times 17 plus 0 is still 0. 1 times 17 is 17 plus -17 is that 0 we were looking for. -5/9 times 17 is going to be -85/9 plus 4 will be -49/9. Now, let's look at that last entry. We're almost finished. -19/9 times 17 is -323/9 plus -25 is going to be -548 over 9. So this was obtained by taking row 3 and replacing it with 17 times row 2 plus row 3. Now we can take row 3 and we're going to replace it because we want a 1 here. I can multiply by the reciprocal. So let's multiply by -9 over 49. So the top two rows don't change. Now, 0 times negative 9/49 is still 0. So these first two entries will still be 0. And then multiply something by its reciprocal and we get 1. And now negative 548 ninths times negative 9/49 will be 548 over 49. Now let's rewrite this as the corresponding system. So we have x plus 4y minus 2z equals negative 3, y minus 5/9 of z equals negative 19/9, and then we have z equals 548 over 49. So let's do back substitution. So let's take this quantity and substitute it back into the second equation. So we have y minus 5/9 of z, which we know to be 548 over 49. And that's going to be negative 19/9. So what's this mean? We obtain y minus 2,740 over 441 equals negative 19/9. Let's add that quantity to both sides. That negative 2740 over 441 will get undone. And so that means y equals 201 over 49. And now we can take that quantity and back substitute along with our z value into our first equation. And so we have x plus 4 times y, which is 201 over 49, minus 2 times z, which we found to be 548 over 49. And this is going to equal negative 3. So this means x plus 804 over 49 minus 1096 over 49 will equal negative 3. So this means x minus 292 over 49 will equal negative 3. And so x equals 145 over 49. So our solution is 145 over 49, comma, 201 over 49, comma, 548 over 49. Always remember that these should be alphabetical. Let's look now at this system. 2, negative 4, negative 16, 3, negative 6, 1. Let's get that first entry to be a 1. So we can do that by multiplying row 1 by 1/2. So the second row will not change. So our first row will be 1, negative 2, negative 8. Now we need this entry to be a 0. So let's multiply this row by negative 3 and add it to this row. So row 2 will be negative 3 times row 1 plus row 2. So we have 1, negative 2, negative 8, does not change. Then we have 1 times negative 3 plus 3 is our 0. Negative 2 times negative 3 is 6 plus negative 6 Well, that's also 0. Negative 8 times negative 3 is 24, plus 1 is 25. Now if we multiply row 2 by 1/25, this is going to give us 1, negative 2, negative 8, 0, 0, 1. Let's rewrite the corresponding system. X minus 2y equals negative 8. 0x plus 0y is just 0, equals 1. But 0 doesn't equal 1, and it never equals 1. So this has no solution. So it's inconsistent. It's an inconsistent system. Let's look at this example. We have 3, negative 5, negative 1, 6, negative 10, negative 2. Let's get this in row echelon form. So let's multiply row 1 by 1/3, and that's going to yield our 1 in the column. So we have 1, negative 5/3, negative 1/3, and then our second row did not change. Now let's multiply. We want to get 0 here, so let's multiply this by negative 6 and add it to our second row. So our new row 2 will be 1/6 of row 1 plus our old row 2. And this gives us nothing but zeros. So let's write the corresponding system. We have x minus 5/3, y equals negative 1/3, and 0 equals 0. This means that there are infinitely many solutions, and so let's go ahead and solve x minus 5/3 y equals negative 1/3 for y, so that we can write our solution. So let's multiply everything here by 3. It'll make it easier. So we have 3x minus 5y equals negative 1. Negative 5y equals negative 3x minus 1. So y equals 3/5 of x plus 1/5. And so there are infinitely many solutions. X comma y, it's the set of all ordered pairs x, y, where y equals 3/5 x plus 1/5. So this system is consistent because there are infinitely many solutions. So as long as there's a solution, it's consistent. What we would say is that these equations are dependent.